Okay, so let's start with the 19th question. Now see, in the 19th question, what is happening? I have written the same question in a little different manner. So I have just turned and written it so it's easier to follow. Now, also I have applied CIP sequence and hence I have broken the double bonds. I have broken the triple bond and I have put only and only single bonds. I have added the dummy atoms. So all those things I have done. You can have a look. And now we will start assigning the priorities. So let's start comparing. If I start comparing, then I can see that here it's carbon, here also it's carbon, 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 carbon. Again here carbon, carbon. So till here everything is same. There's no difference. After this difference starts. So here I have hydrogen and here I have carbon, which means this priority goes to the lower group because carbon has a higher atomic number than hydrogen. So this group gets a priority. Okay. Next part. Again here carbon, here carbon, 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 then here carbon. So till here everything is same. And then again this carbon is connected to carbon, this carbon is also connected to carbon. Till here everything is same. So then how do we compare? Now see, if everything is same, then we'll see which part was broken and which part was not broken. Broken in the sense where was a multiple bond present and where was a multiple bond absent. This portion does not have any multiple bond. I mean, I did not convert this to any other form. Whereas the lower part had a multiple bond. It had a double bond, right? That is why I broke it. So then the part which does not have any multiple bond gets the priority. Now I see that the two priorities are opposite to each other and hence this is E. Coming to the 20th question. Functional isomers. Functional isomers are those which contain different functional groups. If I look at the second option, then here it is ONO and here it is NO2. Hence these two are functional isomers. Here the linkage is through O, here the linkage is through N. So second option is correct. Next question, question number 21. Degree of unsaturation is equal to 3. Degree of unsaturation is equal to 3. That means option D will be correct because in the last option there are 3 rings. If there are 3 rings in a compound, that means degree of unsaturation is equal to 3. Hence D is correct. 22nd question. Potassium iodide contains I minus because iodide means I minus ion. If this is treated with I2, then I get I3 minus. So this is formed and hence correct option is option C. 23rd. Electrolysis of calcium chloride and calcium fluoride. Now here, if you look at this option, that is the first option A. This is correct because everything is fused. What is the meaning of fused? Fused means molten. So only calcium 2 ions can get reduced to give me calcium. Hence I obtain calcium, hence this is correct. The issue with option B is the presence of water. They have used the word solution, and if the word solution is used, that means H2O is present. H2O interferes during electrolysis, and hence I do not obtain calcium. Rather, hydrogen gas is obtained. Hence, we cannot choose any option where water is present. Same issue arises if I take option D, because in option D also water is present. So we can eliminate B and D based on that criterion. Coming to the third option, that is C. There we have presence of Na plus along with Ca2 plus. So the best option will be A, where we have only Ca2 plus and there is no interference from any other species like Na plus or water. Coming to the next question, that is 24th question. Hypo is Na2H2O 3.5H2O, and if I look at the third option, that's C. Then that's correct because Na2S2O3 reacts with AgBr. And this is what is found. So this is a reaction. Hence C is correct. 25th question. 50 ml of 0.2 normal KMnO4 is taken. KMnO4 reacts with HCl to liberate chlorine. If I find out the N factor of chlorine, it will be equal to 2. Correct. Now we know that milli equivalents of KMnO4 reacted will be equal to the milli equivalence of chlorine formed. Normality of KMnO4 is given. Volume of KMnO4 is given. So 50 into 0.2, 50 into 0.2 will be the milli equivalence of KMnO4. That is 10. Also, that is same as milli equivalence of chlorine produced. N factor of chlorine is 2. So I can say that the number of millimoles of chlorine is 10 upon 2. So millimoles of chlorine produced is equal to 5 millimoles. Now, if I look at the next reaction, CH4 is methane. CH4 plus Cl2 gives me CH3Cl plus HCl. Now, see in the question they have mentioned that monochlorinated product needs to be considered. Monochlorinated product means CH3 because only one chlorine is present. Now, according to this, if I say 5 millimoles of chlorine react, it means 5 millimoles of methane also should react. So moles of methane consumed should be equal to 5 into 10 raised to minus 3 because 5 millimoles means 5 into 10 raised to minus 3 moles. This is the correct option. I mean, none of the options given is correct. This should be the correct answer. Hence, this becomes a bonus. 26th question. FeS2 plus O2 giving Fe2O3 plus SO. Now see, I know that according to the law of equivalence, GEQ of FeS2 reacted will be equal to GEQ of O2 reacted, and this is equal to GEQ of Fe2O3 formed and that is equal to GEQ of SO2 formed. X equivalents of O2 are taken. If X equivalents of O2 are taken, that means if X equivalents of O2 react in this reaction, then X equivalents of Fe2 will react. And X equivalents of Fe2O3 will be formed, and X equivalents of SO2 will be formed as per this. Hence, the correct option is A. 27. Now, see, the sample contains Na2CO3 or something else, or a mixture of Na2CO3 and NHCO3, or a mixture of NaHCO3 and NaOH, or only NHCO3. We don't know, because there are 4 different options here. So what we can do is we can check one by one. So let's check the first option. Let's assume that only Na2CO3 was present and nothing else was present along with Na2CO3. When phenolphthalein is used as an indicator, and if only Na2CO3 is present in the sample, then I can say that moles of Na2CO3 should be equal to moles of HCl. Moles of HCl will be how much? 25 upon 1000 into 0.1. Which means the number of moles of Na2CO3 is equal to 25 into 10 raised to minus 4. If only phenolphthalein is used, then I can get this. Now, if methyl orange is used, then what will happen? The equation becomes this. This is the equation if methyl orange is used. Again, I can use the formula, that is volume in liters into normality, because normality is same as molarity for HCl. Hence, directly I'll get the number of moles. And from here, I can say that moles of Na2CO3 will be equal to 25 into 10 raised to minus 4. Why? Because this 2 will come here and I'll get 25. 50 by 2 is 25. Now, see, this is consistent with the previous result, which means that my assumption was correct. That means the sample consisted of only Na2CO3 and nothing else. Because the number of moles of Na2CO3 is coming same in both the cases. So the assumption was correct and A is correct option. 28. Now there is a graph given. There's a graph given. Along the x-axis, velocity is plotted. Correct. And the graph is like this. There are 2 different curves shown for 2 different gases. One is like this, and another one is like this. Now, let this be VA and this be VB. Clearly, I can see that VB is greater than V. V stands for velocity. Now, see, also they have mentioned that this is for A and this is for gas B. This is at temperature T1, this gas is at temperature T2. So I can say now that if VB is greater than VA, then square root of T2 upon MB should be greater than square root of T1 upon M. This is what I can write. If I remove the square root from both sides, I'll get T2 upon MB is greater than T1 upon M. This is what I'll get. Now see, if T2 is greater than T1, if T2 is greater than T1, then T2 upon T1 will be greater than 1. Let us take a value randomly to make it simpler to understand. Let's say that the value is 1.5 because 1.5 is greater than 1. So if T2 upon T1 is 1.5, then 1.5 is greater than MB upon M. This is what I've obtained, right? Now see, there could be three cases. First case is if MB is equal to M. If MB is equal to MA, then this becomes 1 and definitely 1.5 will be greater than 1. So if MB is equal to MA, then definitely I can say that this inequality holds true. That is T2 upon T1 is greater than MB upon M. If MA is equal to MB. What if MB is greater than MA? Now see, if MB is greater than MA, that means MB by MA is greater than 1. Right? Now the value could be 1.7 if it's greater than 1. And T2 upon T1 was assumed to be 1.5. Now is 1.5 greater than 1.7? Is 1.5 greater than 1.7? No. That means it is not necessary that this inequality holds true if MB is greater than M. Hence, option A cannot be correct because the word necessarily is used in the question if you read the question carefully. What if MA is greater than MB? If MA is greater than MB, that means MB upon MA is less than 1. That means T2 upon T1 is definitely greater than MB upon MA because T2 upon T1 is as it is greater than 1. So 1.5 will be greater than anything which is less than 1. Hence, option B is always going to be true. So I can say that B is correct option. Next question. Question 29. Okay. Angular momentum in an orbit for a hydrogen atom is given as 2h by pi. 2h by pi can be written as 4h by 2 pi. This is nothing but nh by 2 pi. We know according to Bohr model, nh by 2 pi is equal to angular momentum, which means the value of n is equal to 4. Fourth orbit is being talked about. Now see if the orbit is fourth and if transition takes place from this to the ground state, then what are the necessary transitions that can happen? So one will be from fourth till first, one could be from third till first, one could be from 2 to 1. I mean, I'm just talking about those transitions wherein the electron jumps till the ground state because in the question they have mentioned that the transition is up to the ground state. Now ground state means the lowest value of so what happens if the transition happens from the fourth orbit till the first orbit? I will say that the energy of the photon will be given by this method, that is energy of the fourth orbit minus energy of the first orbit. Okay. Similarly, I can say that energy of a photon emitted when the transition happens from the second orbit till the first orbit will be equal to the energy of the second orbit minus energy of the first orbit. Now see, they have mentioned that the energy is third highest. I mean, third highest energy means what? We know if the gap is more, let's say from fourth till first, the transition takes place, then a higher amount of energy is emitted as compared to the energy which is emitted when the transition happens from third till first. This in turn will be higher in value as compared to the energy which is emitted when the transition happens from 2 till 1. That means I can say that the third highest energy is nothing but the transition which happens when the electron jumps from the second orbit till the ground state. So the energy of the third highest energy of the photon will be equal to energy of the second orbit minus energy of the first orbit, and that is equal to 13.6. I'm taking electron volt z square, right? Up 1 by n2 square minus 1 by n1 square. This will be equal to 13.6 1 square, because for hydrogen z is 1, into 1 by 1 square minus 1 by 2 square. Now this will be equal to 10.8 electron. Now 2x by 5 is mentioned, right? So 2 into 10.8 upon 5. 2 into 10.8 upon 5. Okay. I'm sorry, I've made a mistake in the calculation, I believe. This is 10.2 and not 10.8. Okay. Now it's correct. So this comes out as 4.0. But then in the question, they have mentioned the word approximate. What have they said? They said that 4.08 needs to be rounded off. Now, how do we know that it needs to be rounded off? Because they've said that has an approximate value of. Whenever the word approximate is used, that means rounding off needs to be done. 4.08 will be rounded off to 4, and hence 4.00 will be the final answer. 30th question. Two acid solutions are titrated separately, each with 25 ml of one normal in this solution. Okay. Now see, let x ml be the volume of acid A used, and let y ml be the volume of acid B used. I'm sorry, let x be the normality of acid A used, and let y be the normality of acid B used. Okay. So if x is the normality, then I can say that x is the normality of the acid. Then I can say that x into volume is equal to 1 into 25. I have used N1 V1 is equal to N2 V2 for acid A. So this is this. That means this is normalities of acid A. Similarly, I can use this concept for finding out normality of acid B. So y into 40 is 1 into 25. Y will be equal to 0.65. This is going to be for acid. Right. We have found out the normalities of the two acids. Now let's read the next part of the question. Find out the volume ratio of acid B and acid A, which should be mixed to prepare 1 ml of one normal solution. That means what is happening? I'll explain this part. Many of you may have got confused after reading the statement. Now see, they are mixing two acids. They are mixing acid A and acid B. They are mixing in such a manner that the resultant normality is 1, and also the total volume of the solution is 1 ml. After mixing, the total volume is 1. Now let's say V1 and V2 are the two different volumes in ml of acid A and B respectively. So V1 ml is for A and V2 ml is for B. I know that V1 plus V2 should be equal to 1. V1 plus V2 should be equal to 1. How do I know this? Because I've mentioned in the question that 1 ml of one normal solution needs to be prepared. 1 ml of one normal solution needs to be prepared. That means the total volume of the solution is 1 ml. So V1 plus V2 is equal to 1. Now, total milli equivalents. Total milli equivalence will also be equal to 1 because normality is given as 1 and volume is 1 ml. So 1 into 1 becomes 1 MEQ. Now also I can find out total milli equivalence in this manner. That is milli equivalence of A plus milli equivalence of B. Milli equivalence is what? Normality into volume in ml. V1 into normality of A, how much is it? 2.5. And V2 into 0.6. So 1 is equal to 2.5 V1 plus 0.625 V2. If I divide both sides, then what will happen? So let's divide. Then I'll get 1.6 is equal to 4V1 plus V2. I have divided by 0.65. Okay. And V1 plus V2 is equal to 1. So V2 is equal to what? V2 is equal to 1 minus V1. Now ratio. Volume of B upon volume of A. That's what they have asked. So V2 upon V1 is asked. Hence answer is 4.0. Question 31. How many of the following orders are given correctly? Now see, all of these are correct. We know that one will be incorrect. I mean, one is incorrect. Which one is incorrect? The fifth one is incorrect. Now this is a fact-based thing. You should remember that the enthalpy of formation of CSCl is higher than the enthalpy of formation of LIC. Hence, fifth is wrong because in fifth, the order of enthalpies of formation is incorrect. Now, why is it incorrect? Because in the order they have mentioned LICl at the beginning, whereas CSCl is mentioned at the end. Now that's wrong because just now I told you that the enthalpy of formation of CSCl is greater than the enthalpy of formation of LICl. The rest all orders are correct. So answer is 6.00 for this. Okay, we will go to the next part. Question number 32. How many of the molten state compounds liberate hydrogen gas at anode during electrolysis? Now see, if hydrogen gas has to be liberated at anode, then this is what has to happen. This half reaction occurs on anode, then only hydrogen gas will be liberated. Now, if you notice, you will realize that you need H minus ions. H minus will come from an ionic compound, that is when hydride is present. Out of all these compounds, BeH2 is covalent. We know that beryllium hydride is covalent, which means BeH2 does not contain H minus. If BeH2 does not contain H minus, then how will this reaction happen? Which means BeH2 does not liberate H2 on anode because it does not contain H minus ion. Hence the answer is 5.00 because out of 6, only one is not going to contain H minus. Rest all are ionic compounds, and ionic compounds contain ions. And the anion in every ionic compound in this case is going to be H minus, which on oxidation will liberate H2. Question number 33. How many of these exist only in the solution state? Now remember that LiHCO3 and the bicarbonates of alkaline earth metals do not exist in solid state. LiHCO3 and bicarbonates of alkaline earth metals do not exist in solid state. That means they exist in solution state. So the answer is 4.00. Alkaline earth metals are the elements of group 2 of periodic table. So magnesium bicarbonate, calcium bicarbonate, barium bicarbonate, these all will exist in solution state. Right. Question 34. How many atoms of bromine are present in one molecule of bromoform? Now see CHCl3 is chloroform. So CHBr3 will be CH. So in one molecule of bromoform, there are 3 bromine atoms. Correct. So 3 upon 4 is what I've asked for. So 0.75 will be the answer. In one molecule of cyclohexane carboxamide, there are X atoms of carbon. Find X by 5. This is cyclohexane carboxamide. I can see that there are 6 carbon atoms here and there's 1 carbon atom here. So there are 7 carbon atoms. 7 upon 5 is 1.40. This is what they have asked for. 36th question. Find the maximum number of atoms lying in the same plane in C2FClBrI. C2FClBrI. Calculate the degree of unsaturation first because the molecular formula is given to us. So C minus H by 2 minus X by 2. This is the formula. One. Correct. Okay. So there is 1 pi bond. Whenever degree of unsaturation is equal to 1, that means that there is 1 pi bond. Pi bond can happen between carbon atoms because halogens don't form pi bonds, right? So carbon, carbon. And hence I can say here F, let's say here Cl, I put Br here and I here. Now this is sp2 hybridized. This is also sp2 hybridized. Hence I can say F, this carbon and chlorine lie in the same plane, and this carbon also lies in the same plane, which means carbon, carbon, fluorine, chlorine lie in the same plane. Similarly, if I look at this side, that is, if I look at the groups attached to the right-hand side carbon, then bromine, iodine are connected to the same carbon, and hence I can say bromine, carbon, and iodine lie in the same plane because again this carbon is sp2 hybridized. Also, I just now figured out that this carbon and this carbon lie in the same plane because both the carbon atoms are sp2 hybridized. So all the atoms are lying in the same plane, and I can say this is a planar molecule. And if something is planar, that means everything lies in the same plane. 1, 2, 3, 4, 5, 6. There are 6 atoms here, and I can say that 6 atoms lie in the same plane, and hence the answer should be 6.00. So answer is 6.00. If you still have any doubt, you can ask me. Thank you.